Hello, welcome to CSC7013, Advanced Math for Computer Scientists. This is Brady Chen. This is Module 6, Set Theory. Set theory is the mathematical theory of well-determined collections called sets of objects that are called members or elements. Now here's the learning objectives for Module 6. Now first we will introduce the concept of sets, and then we'll talk about the relationships between sets, the relations between sets. And we will talk about some of the operations on sets. So we introduced the concept of sets and discuss the relations between sets. So now here we're going to talk about some of the operations on sets. Okay, so basically there are three operations. Okay, these are three basic operations. One is called a union, and then intersection and a complement. Okay, so for example, if we assume A is a set of birds and B is a set of cats, so A and B are different sets. Now, based on the discussions in the previous slide, we know that A and B have nothing in common, right? So these are disjoint sets. However, can we actually do any kind of operation, perform any kind of operations, for A and for B? So we can actually create a new set based on these two sets. So that's something we're going to talk about. So let's look at the first operation, the union. Now we use the notation A union B. Okay, suppose A is a set and B is a set, then A union B, we use the notation, looks like a English letter U. Okay, now to define union, let's consider two definitions of the same operations. Okay, so you can define the union in two different ways. Okay, now definition one, it's based on the elements of these sets. So to make a union of A and B, take all the elements of A and all elements of B. You take all elements of A and all elements of B and put them together, and the resulting set would be A union B. Okay, so this definition is based on the elements of the sets. Now the second one, we can define the union like this. Okay, suppose if you have element X, if element belongs to the A union B, if and only if A belongs to A or X belongs to B. Okay, so that defines the union of A and B. Now let's take a look at the example. Just use the example of previous slide. If A is the set of birds and B is the set of cats. Okay, now what's A union B? So based on the definition 1, basically and union B, and the set is the set of birds or cats, right? So that's the definition of union. That's the example that how we can actually combine two sets together and create the union of these two sets. Okay. Now let's take a look at some more examples. Okay. Now, first example, suppose A is a finite set which contains some numbers 1, 2, 3, 4. Okay. Now B contains 3, 4, 5, 6. Okay. So let's see, what is A union B? So you basically use the definition 1. You can put all the elements in A and all the elements in B together. There's actually redundant, right? So we just need to take one copy. So you have a 1, 2, 3, 4, and then B has a 3 and a 4, so it's already included. So we just put the 5 and the 6. Okay, so that's A union B. Remember, for every set, you cannot have a redundant element. Okay, so one of the element has to be appear once in the set. Let's take a look at another example. Okay, suppose I have a set. I can use different notation instead of A and B. I can say X equals the set of all numbers divisible by 3. And Y is the set of all numbers divisible by 2. Okay, now what is A X union Y? It's a set of all numbers, because remember the definition, you just combine all the possible elements from A and all the possible elements from B and together. So the set of numbers divisible by 2 or 3, right? So if it's divisible by 3, that means that element belongs to X. So this element should be in the union of X and Y. Now if the number is divisible by 2, so that element belongs to Y. But that number should also belongs to X union Y, right? So that X union Y should include both the element, okay, the element both either belong to X or Y. So that's another example of the union X and Y. Okay. Now let's take a look at the other example. Let's say, okay, I'm going to use A, the set of all even numbers. B, the set of all odd numbers. Now what is A union B? So the A union B is going to be the set of all even numbers all odd numbers. Okay, what does that mean? So it's a set of all whole number, right? Okay, whole numbers. Let's see, any other example? Okay, let's take a look at the last one. We can use I is the set of all negative numbers, and J is the set of all positive numbers. What is I union J? Yes, the I union J is a set of all positive or negative numbers. Okay. You cannot say it's the set of all whole numbers, because if you want to claim the set contains all whole number, you have to include 0. But I union J does not. This is a new set, but it does not contain 0. Okay. Or you can say I union J is the set of all non-zero whole numbers. That should be okay, right? It does not include 0. Now here's another operation. It's called intersection. Now for intersection, we use the notation A intersection B. It looks like the English letter U, but it's upside down. Okay. Now to define an intersection, let us consider two definitions. Again, we have two definitions. Definition 1 and definition 2, which are very similar to the definitions for the union. Okay. Now first, to make an intersection of A and B, suppose we have two sets, A and B. And to make an intersection of A and B, take only those elements of A and B that belongs to both sets. The resulting set will be A intersection B. Or we can use another definition. Definition 2 says, if an element X belongs to A intersection B, if and only if X belongs to A and X belongs to B. Remember the and, because for union it only say X belongs to A or X belongs to B. But now for intersection, we have to make sure X belongs to A and X belongs to B. Okay. Now you can clearly see the difference between the union and intersection, right? So now take a look at the example. Okay, again, let's say A is a set of people who speak English. Who speak English. Okay, English. And B equals a set of people who speak Spanish. Okay, now what is A union B? So that's the set of people who speak both English and Spanish, right? So therefore, if you know that the X is in the intersection of A and B, then X must be in A and B. Now, let's go back to another example. A is the set of birds, right? And B is a set of cats. Now, what is A intersection B? It's a set of animals, so that means it belongs to both A and B. So that means that animal must be both birds, both a bird and a cat. That's not possible, right? So there's no overlapping between A and B. So A intersection B must be an empty set. So there's nothing in there. Sometimes we use phi to represent an empty set. Okay. Now let's take a look at more examples of intersection. So we're going to use the similar examples that we used for the union. So let's say A is a finite set 1, 2, 3, 4, 5, and B is another finite 8, 3, 4, 5, 6, 7. Now what is A intersection B? So we remember by definition, for every element in the intersection of B, that element must be in both A and B, right? So let's take a look at each of the elements in A. So we look at the number 1. 1 is in A, however 1 is not in B, right? So 1 should be excluded. 2 should be excluded because it's not in B. Now 3 also appears in B. 4, yeah, 4 is in A, but also in B. And 5, yeah, in both A and B. Now the other element 6 is in B, but not in A, right? 7 is in B, not in A. So these should be excluded, right? So A intersection B should be 3, 4, and 5. Okay. Now let's take a look at another example, X. Let's say X is the set of all numbers divisible by 3. And Y is the set of all numbers divisible by 2. Remember A union X union Y, right? X union Y is the set of all numbers divisible by either 3 or 2. Okay. Now what is the intersection? What's the intersection of X and Y? Again, if X belongs to X and Y, that means X must be divisible by 3. But in the meantime, X must be divisible by 2, right? So what is the intersection of X and Y? So it's a set of all numbers divisible by both 3 and 2. Now what kind of number that are divisible by both 3 and 2? So you can, for simplification, I think that's good enough. Okay. That should be well defined, the X intersection Y. But you can simplify these. You can say, okay, if divisible by both x3 and 2, then it's a set of all numbers divisible by, you can multiply 3 and 2 by 6. Now these are the same set. So it's actually a simplified version, but anyway, it doesn't make any difference. You can also just express the X intersection Y with that statement, but you can use that one as well. So that's the examples of intersection. Let's take a look at another one. Say I is the set of numbers. Okay, I'm gonna say set of all even numbers. And J is the set of all odd numbers. Okay. Now remember I union J, right? So it's the set of all even or odd numbers. But what is I intersect J? Intersection J. Can we find a number that is even number, but also in the meantime it's a odd number? The answer is no, right? So that means what does that mean? So the intersections of I and J should be empty set. Okay. Now complement is another operation. So we use the notation A to the C to represent the complement of A. Okay, so A to the C is a notation for complement of A. Now also we can define the complement in two different ways. So definition 1, to take a complement of A, take only those elements of universal set that are not in A. Then the resulting set will be the complement of A to the C. So in that case, in order to define a complement, we need to agree on a universal set. Okay, what is universal set? It's a set of objects under consideration. So when we actually talk about a complement, you have to, we have to agree on what's the set that include every element we're considering. Okay. Now the other definition is, so if an element X belongs to the complement of A, so suppose a complement of A is another set, then if and only if A does not belong to A. So if A does not belong to A, then A belongs to the complement of A, or vice versa. That's the second definition. Now, with the concept of complement, then the question is, what would be the complement of a universal set? So the universal set supposed to basically contains all the elements we're considering. Now the complement of the universal set, that means the element in the complement of the universal set basically belongs to something that other than the universal set. So that means basically it does not exist, right? Because the universal set already contains everything we are interested in, but the complement of a universal set basically contains nothing. So that's, we use the empty set. So basically the universal set and the complement of the universal set U to the C is actually the empty set. So let's take a look at the example again. So we think about the set of numbers let's say divisible by 3. Okay. Now, what's the complement of C? So the first thing we need to figure out is, in order to define the complement of X, we need to figure out what's the universal set. Now, logically, we can assume the universal set is the set of all numbers, or whole numbers. And then, so the complement of C basically is a set of all of numbers not divisible by 3. Okay. Every numbers. As far as they're not divisible by 3, then that's the complement of C. Okay. Now again, if X is the set of numbers divisible by 2. Now what is X complement? A complement of X. So it's the set of numbers not divisible by 2, right? That's definitely correct. But also we can say it's a set of numbers not divisible by 2, or it's a set of odd numbers. Now, the set of numbers divisible by 2 can be viewed as a set of even number, right? Even numbers. Okay. So that's the other example. Let's see what else we can talk about. Yeah, okay. Let's think about another example. Let's say A is 1, 2, 3, 4, 5. B is 3, 4, 5, 6, 7. Now, in order to talk about the complement of A, or complement of B, now we need to define the universal set, right? So of course we can say, okay, let's define the universal set as all numbers, all whole numbers. Then the complement of A should be all the numbers except 1, 2, 3, and 4, and 5, right? That's fine, no problem. And the complement of B is basically the set which contains all the numbers except 3, 4, 5, 6, and 7, right? Now, if we define the complement as this, the universal set for A and B as 1, 2, 3, 4, 5, 6, 7. Okay. So suppose the universal set is actually the union of A and B. So that include the elements belongs to both A and B. Oh, belong to A and B. Okay. Then what's the complement of A? Now, if the universal set is also finite set, the complement of A should be the set which contains the element of U, but not in the element of A, right? So what is A complement? The complement of A. So 1, 2, 3, 4, 5 should not be in the complement of A, but 6 and 7, right? Okay, so that's the other example. So before we talk about a complement, it's important to define the universal set. Okay. Okay, so let's summarize all the notations and all the definitions we have covered so far. Okay, so we we have talked about the sets, right? And also we talk about three operations, A union B, A intersection B, and the complement of A. And also, as a special set, we call it the empty set. The empty set is a set that contains nothing. So no elements actually is contained in the empty set. The universal set is the set that contains all the elements we are considering. Okay, so that's why empty set and the universal set are pretty much the opposite, right? So that's why always remember the complement of empty set is a universal set, and the complement of universal set is the empty set. That is just the opposite. And we also can talk about a subset, right? We use A included in B. That's a subset. We use the notation belongs to, so if X is an element of A, we just say X belongs to A. And X does not belong to A. Okay, these are all the notations we're going to use. Just keep that in mind. Now, based on the definitions of the union, the intersection, and the complement, then we have some useful consequences of these definitions. Okay, so since remember, if we say if X belongs to the union of A and B, if and only if we use IFF, X belongs to A or X belongs to B. You know, either X belongs to A or X belongs to B. So what does that mean? That means that if X does not belong to the union of A, if X does not belong to the union of A, that means X does not belong to A, and X does not belong to B. Right? It's pretty straightforward, because if X belongs to A, that means X must be in the union of A and B. Or if X belongs to B, then X must be in the union of A and B, right? Based on the definition. Okay, so if X belongs to A, then if and only if X belongs to the union of A and B. So that means if X does not belong to A and A union B, then X cannot be in A and B. So that's one of the consequences. The other one, if X belongs to union A, no, I'm sorry, X belongs to the intersection of A and X and Y, then X must be in X and X must be in Y. That's pretty straightforward, right? Because that's the best definition. Okay. Now, if X is in the complement of SC, then X does not belong to. Okay. Oh, let me see. There's some typo here. Okay. Let's see. Okay. It should be X belongs to A, then X does not belong to the complement of A. Okay. Or vice versa. X does not belong to A, then X cannot. If X does not belong to A, then X must be in the complement of A. So I think that's a typo. That should be A. Okay. Okay, let's take a look at some more examples. I think I can answer some of the questions, but you can actually, figure out the rest. Okay. Suppose A is a set of all positive even whole numbers. Okay, or A is all the positive even numbers. B equals all the positive odd numbers. And U all the whole numbers. So that means that's the universal set, right? Now please answer whether each of the following statement is true or not. Okay. So 246 belongs to A. Is that true or not? Let's take a look at the definition of A. So A is all the positive even whole numbers. Okay. So is 246 a positive even whole number? Yes, it is positive. It's an even number, right? So the answer is true. Or A 0 is 0 belongs to A. So again, A is all the positive even whole number. Now is 0 positive or even number? A looks like a 0 is an even number, but it's not a positive, right? So 0 is definitely not in A. Now what about this? Minus 39. Is minus 39 belongs to B? Let's take a look at B. Or B is all the positive odd number. All the positive odd number. Minus 39, it is an odd number, right? But it's not a positive, right? So that's false. Okay. Now, let's take a look at this. 34,545. Looks like that's a whole number. Is the number belongs to A union B. Now, what is A union B? We need to figure it out. A is all the positive even whole numbers. B is all the positive odd numbers. So that means all the positive even or odd numbers. That's odd numbers. So as far as that number is positive, it doesn't matter whether it's even or odd. It should be in A union B. So the answer is true, right? Now, this one, 55. Is 55 belongs to A intersection B. Now, first we need to figure out what is the intersection of A and B. A is all the positive even whole numbers. B is all the positive odd numbers. Can you find a number that is both even number and a positive number? The answer is no, right? So A intersection B is an empty set. So of course 55 does not belong to an empty set. False. Okay, let's finish off. Okay, so A union B, all the positive even or odd numbers, but 234, that's a positive even whole number, right? But by definition, A union B should be all the positive even number or odd numbers. So 234 is actually in A union B, right? So that's definitely a false statement. It says 234 is not in A union B. That's not true, right? And what about this? Minus 111 does not belong to A union B. True, right? because every number does not belong to A union B, because A union B is an empty set. Okay. Oh, I'm sorry. A intersection B is an empty set. Okay. So what is A union B? So we already answered the question. What is A intersection B? We already answered the question. So that's B is an empty set. A union B is actually a positive, even, or odd numbers. Okay. So what about this? Is the following statement true? A union B to the C. So that's a complement of A union B. Okay. Now remember, universal set is all the whole numbers. So A union B says it's all the positive or odd or even numbers. Okay. Now what's the complement of A union B? So that means it should be all the whole numbers that are not even number, positive even number, not a negative, oh, I'm sorry, not a positive even number, not a positive odd number. So it should be all the negative whole number. Is that true? Actually, this is not true. Why? The complement of A union B include all the negative whole number. That's true, but also should include 0, right? Okay. So if you think about the whole numbers, the universal, so basically you include 0, 1, 2, 3, all the way, and -1, -2, -3, da da da. So A union B actually is actually all the positive whole numbers. So the complement should be all the negative whole number plus the 0. Remember that. So if we cut it half, so that's A union B, and that's A union B to the C, the complement.